This will be our final video dealing with the review guide for the final exam. This is Chapter 9, Part 3, dealing more with trigonometric functions. Now we're going to be dealing with graphing. Um, so the first one here, we're going to draw a sine curve. So now a sine curve starts on 1, 2, 3, 4. Sine curve starts on the midline, so you're going to put a dot on the line, then off, on. So there's just the graphing of the sine curve. Notice that I didn't do any of the numbers yet, but there's the sine curve. Now, let's talk about the 3 that's in front and the -2 at the end. That is where the midline is located. So the midline is located at -2, and the amplitude going up and down is 3. So there's at least a measure of where your midline is located and where your amplitude is located as well. Now, the middle of the graph, notice it's x minus pi over 4. So pi over 4 will be where the phase shift occurred. Normal period length is 2 pi divided by b. Since there isn't a b value here, then the period length for this one is 2 pi. The interval length then, interval is always taking the period length divided by 4, because there's 4 quadrants going around. And so now we're going to add pi over 2 going to the right and subtract pi over 2 going to the left. So we end up with 3/4, 5/4, 7/4, 9/4. Going the other way now we'll get negative pi over 4, negative 3 pi over 4, negative 5 pi over 4, and negative 7 pi over 4. If you want to know where 0 is located, so if you wanted to draw in the y-axis, it's located between the positive and the negative, so it'd be located right there. Next one. It's a negative cosine curve. So let's draw in that midline again. 1, 2, 3, 4. 1, 2, 3, 4. This one's going to start off the axis, off the midline, sorry, and it's going to start below the axis. Now, again, drawing in the cosine curve. So there's just negative cosine. So dealing with what's on there so far, we've done the negative sign, the reflection, and the fact that it's a cosine curve. Now let's talk about the +1 at the end. So the midline is at 1. The amplitude is still 2. The fact that it's a -2 doesn't really make any difference. So you're going up to 3, down to -1. Next, we want to talk about where the phase shift occurs. So negative pi over 2. And now the period length. Period is always 2 pi divided by b. So 2/3 divided by 3, or excuse me, 2 pi divided by 3. And then you take that divided by 4. So the interval in this case is pi over 6. And so you're going to add pi over 6 going to the right and subtract pi over 6 going to the left. So here we have adding pi over 6. Whoop, my fault. Hold on. Adding pi over 6. Adding pi over 6. And subtracting pi over 6. 0 would be located right here. There's the next one. I have a tangent curve. So first, drawing that midline. I'm still going to do 4 to the right and 4 to the left, even though the period length has changed. Tangent is sine over cosine. So draw a cosine curve. Every time the cosine curve hits the midline, it causes an undefined. So draw in your asymptotes. And then tangent goes upward. So it starts low, goes along the asymptote. Next, Let's talk about where the midline actually occurs. So the midline will occur at 5. Notice the end number at the end. No number in the beginning, so you're talking about a 1. Again, this is merely for scale. There isn't an amplitude for tangent, but it gives you a scale as to where the points would be located. And now we're going to talk about the phase shift. In the middle here, we have a pi over 3. Period length for a normal tangent curve is pi divided by b, and since there is not a b value, and so the interval in this one is divided by 2 this time instead of dividing it by 4, because again, period length is only pi, so there's only 2 quadrants. If a period length is 2 pi, then you divide by 4 because there's 4 quadrants. So now I'm going to add pi over 2 going to the right, so adding pi over 2 each time here, and subtracting pi over 2 each time. And that's a tangent curve. Next one is a cotangent curve. Again, we're going to draw in our midline. Cotangent is cosine over sine. So we're going to draw in a sine curve. Every time the sine curve touches the midline, it will cause an asymptote. Cotangent goes from high to low, so we're going along the asymptote through the midline. On the asymptote through the midline. All right, let's talk about the midline. 0, there's no number being added to the function, and going up and down. Now, again, no amplitude, but this gives us a basically where the points would be located. Negative pi over 6 is our phase shift. Period length is normally pi divided by b. And so in this case, dividing it by 2, we'd end up with pi over 6. So I'm going to add pi over 6 each time along here. So if I add pi over 6, add pi over 6, going to the right, subtracting pi over 6, to fill out the graph. And then 0, if you wanted to put 0 in right there. Secant curve. Draw in your midline. 1, 2, 3, 4. 1, 2, 3, 4. Secant is 1 over cosine, so we're going to draw in a cosine curve. And every time the cosine curve hits 0, it will cause an asymptote. Now, instead of tangent and cotangent, these will make U shapes along the asymptotes through the point of your cosine curve as it's and so there you go. Now all I've done so far is drawn a secant curve. Let's talk about the midline now. 1, it goes 1 is being added to the function. The amplitude, or what's going up and down for this particular function, is also 1. Phase shift in the middle. Now, I didn't do this earlier. We have to take out a 3 so that we can do our phase shift. We have a pi over 12 right in the middle. So we have a phase shift of plus pi over 12. Period length. Period length is always 2 pi divided by b. So the interval for this one divided by 4 is pi over 6. So I'm going to add pi over 6 going to the right and subtract pi over 6 going to the left. So I'm going to add pi over 6. I get pi over 4, pi over 12. And then subtracting pi over 6. Again, 0, if you want to draw in the y-axis, it'd be right there. Last one of the graphing, we have a negative cosecant. So draw in your midline. 1, 2, 3, 4. 1, 2, 3, 4. Cosecant is 1 over sine. So you're talking about a sine curve, but it's a negative sine curve. So notice that I went the opposite direction for my sine curve. Each time it hits the midline causes an asymptote. U shapes, just like secant. Cosecant is very similar to that. So we have U shapes using the points from our sine curve that we had earlier. -1, up and down 5. So if I go up 5 and down 5, phase shift, the middle is at pi over 2. And now period length. Interval, take the period, divide by 4. And so I'm going to add pi over 2 going to the right and subtract pi over 2 going to the left. So if I add pi over 2 each time, going to the right, and subtract pi over 2 going to the left. And there it is. Next, describing the graph. Okay, now this is where you're using your vocabulary. If there's a negative sign out in front, we're talking about reflection on the x-axis. A number out in front, you're talking about a vertical stretch or vertical shrink. A number multiplied in the parentheses, you're talking about a horizontal stretch or shrink. Translations left or right, and then outside translations up or down. So the first one here is a vertical shrink. By 1/3. I'm going to draw a line in there. We got a horizontal shrink by 1/2, and a translation to the left, pi over 4. The other one, reflection on the x-axis. Vertical stretch by 4. Another translation, this time to the right, pi over 2. And another translation up 1. Next, we're actually going to write the rules. So we're going to write g of x, and we're going to translate to the right, pi over 2. So that causes inside the parenthesis. So here's the original cosine. Oops, hold on a second. Let's erase this. Cosine x minus pi over 3 plus 6. If I want to go to the right, I'm going to need to subtract. So if I'm going to the right, I'm subtracting pi over 2. So my new one now, cosine x minus 5 pi over 6 plus 6. And next, they're going to ask me to do a horizontal shrink by a factor of 1/2. Now, you are replacing x with 2x. Common mistake here is to go ahead and put that out in front. That's what you do when you end up graphing it, but not what you do when you're actually doing the horizontal shrink. Translation 5 units up. So let's do that first. I'm going to add 5. And then I want a vertical stretch by a factor of 4. Now, that's taking this entire function times 4. So g of x equals 4 sine of x plus pi over 3 plus 8. All right, they are giving me a restraint. They're telling me where to graph this at. They're telling me to graph this in the 4th quadrant, and they're telling me that secant, which is the opposite of cosine, So hypotenuse and adjacent is 3. Now, that makes the other side the square root of 8, or 2 square roots of 2. So now, filling in all of your trig functions based on this angle here, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Now, it gets a little trickier with cosecant. You end up with 3 over 2 square roots of 2. So now multiplying top and bottom by the square root of 2. Same with cotangent. You got to multiply both the top and the bottom by the square root of 2. Next one, simplify each. So our first one is cotangent x, sine x, secant x. You're multiplying all those together. So that you basically need to get this all in cosines and sines. So cotangent is cosine over sine times sine. I don't want to make that look like it's in the denominator. Times sine times 1 over cosine. All right, so now sine would cancel with sine. Cosine would cancel with cosine. I'm left with 1 as the correct answer. This is all on your formula sheet, which will be given to you. That's a negative tangent x. This would be a cosine x. Tangent is sine over cosine. Cancels, leaving you with, don't forget about the negative, sine x. All right, things get a little trickier now. Anytime you see a binomial that is not squared, so it's not a Pythagorean identity, you should multiply by the conjugate. The conjugate is cosecant x minus 1 for the first one, cosecant x plus 1 for the second one. So this is what you're going to end up with. And I'm going to draw this out pretty big here. I'm going to FOIL, so I'm going to multiply both top and bottom here. I'm going to get cosecant x squared minus 1, cosecant squared minus 1. And I'm going to distribute on the top. So I've got sine x cosecant x minus sine x. On the other side, I've got sine x cosecant x plus sine x. These two on the bottom, and I probably should have used a different color here, is a Pythagorean identity. Cosecant x squared minus 1 is equal to cotangent squared x. Cancels. I'm left with 2 sine x cosecant x. Now, cosecant is 1 over sine. So this is 1 over sine times sine. So now I'm down to 2 cotangent squared x. And doing the reciprocal property, it's 2 tangent squared. Last one, is there anything I could take out of both of these? Well, they both have a GCF of sine. This is a Pythagorean identity. Cosecant squared x minus cotangent squared x is 1. And so the answer is sine x. Notice that I took out the verify questions. There are no verify questions on the final exam. The only questions you'll have will be the simplify questions on the final. All right, so now our last section here. I need to come up with 2 numbers that will get pi over 12. Okay, now you know everything about pi over 4, pi over 3, pi over 2, pi over 6. So I would think about all of these as being over 12. So this would be 2 12s, and this would be 12s. And this is 3 12s, and this is 4 12s, and this is 6 12s. So I'm trying to use these to get pi over 12. Right here, these two. Couldn't I easily do sine 3 pi over 12 minus 2 pi over 12. So basically what I want is I want pi over 6 minus pi over 4. Let me try that again. I want pi over 4 minus pi over 6. I had it backwards. All right, you ready? Draw a picture for pi over 4. 1, 1. Square root of 2. Pi over 6 is a 60-degree reference angle. 1, square root of 3, 2. And so now, using our sum formula, this is the sine of pi over 4 cosine pi over 6 minus, so that minus sign goes in the formula. It doesn't go in the actual angle measure that you're drawing here. Cosine pi over 3 sine All right, hold on. So I've got pi over 6. This one would be cosine pi over sine pi over 6. I'm going to pause here for just a second here. We got a little bit of a technical issue going on here. So sorry about this, everybody. Apologize for the confusion there. We had a little technical issue. And as I was looking at this, the picture down here should have been for a 30-degree angle. Pi over 6 is a 30-degree reference angle. So sorry about that. All right, so here we go. Sine of pi over 4. I look at the sine. I do the sine of pi over 4. Cosine pi over 6. Cosine pi over 4. Sine pi over 6. So now, multiplying and like terms, I get the square root of 6 minus the square root of 2, all over 4, 2 times 2. Next one, negative 5/12. Again, using the same angle measures we had before, I'm going to use a negative 3/12 minus 2/12, which breaks down to negative pi over 4 minus. Now, you can change this into a plus, a negative if you want. If that makes more sense to you, then you're dealing with a negative angle measure and you're using the plus formula. You can use it, keep it as a minus sign, and then you just have to make sure you do a positive angle measure. So drawing the picture for both of those, I've got a negative pi over 4 and a negative pi over 6. Cosine with a plus sign. It's cosine of the first, cosine of the second, minus sine of the first, sine of the second. And now it's a matter of looking at the picture and putting the correct ratio now. Cosine negative pi over 2, or negative pi over 4, is the square root of 2 over 2. Cosine, square root of 3 over 2, minus negative square root of 2, and you probably should use parentheses around each one of these. It makes it a little easier. Negative a half. And so our final answer now, I get the square root of 6 over 4 for the first one, and a minus square root of 2 over 4 for the second. Before you even get started on this one, they are giving you find the exact value of the trigonometric function given that sine of A is 4/5 and it is in the second quadrant. So draw a picture in the second quadrant where sine is 4/5 and find the missing side. Do the same thing for the other one. They're giving you that cosine is in the fourth quadrant and it's 12/13 and find the missing side. So that is what you are given in the directions. Now, they want cosine of A plus B. Using our formula, it's the cosine of A, cosine of B, minus sine A, sine B. Now, the first one here, this is A, and this is B. So as I do these, I'm going to do everything for those particular pictures. Cosine, adjacent over hypotenuse. Cosine of the next one, adjacent over hypotenuse. Minus sine of the first one, sine of the second one. So I get negative 36 over 65 plus 20 over 65 makes negative 16 over 65. Last one. It's a tangent question. You actually have the same direction. So the pictures that you just had previously are here again. So same directions. So I'm going to redraw those two pictures that I just had. This one was A, this one was B. Tangent. Tangent is the most complicated of the formulas. Tangent A plus tangent B over 1 minus tangent A, tangent B. So now looking at A, tangent is adjacent over, excuse me, opposite over adjacent. Tangent of B, opposite over adjacent. And then negative 4/3 times negative 5/12. Little fractional skills here. Adding the top, you get negative 21/12. Adding the bottom, you get 16/36. And so now, negative 21/12 multiplied by the reciprocal cancels. I'm left with negative 63/16. That concludes our final exam review guide. Hopefully you were able to get something out of this. If you have any questions, please ask myself or Mr. Bone. We'll be happy to help you. And good luck on your final exam.